Dear students, consider the trial assessment problem. Consider we have a 4 nodes 0, 1, 2 and 3, and this is the distance from 0 to 1, 1 to 2 and 2 to 3, and from 0 to 2. So all over we have a distance 10, except from 0 to 2 we have a distance 17. We can represent in the form of matrix. Since it is a reflective matrix, we can do the calculation to one part of it. Because from 0 to 1 the distance is 10, it is same as from 1 to 0. That is why for the optimization we can calculate, or we can consider the matrix over the one side. Beginning with step 1, initialize important parameters. So here the population size they have taken is 4. Here, since we are taking the trial assessment problem, we have 4 nodes which is equivalent to 4 ants. So we have taken the population size as 4. Maximum iteration we have taken here as 2. The same can be repeated during your exams. Pheromone evaporation, that is 36%. So 36% means 0.64% remains. So initial phenomenon or the artificial phenomenon will be 0.5. Alpha value is 1, beta value is 1, and constant that we have to take, we have to initialize initially is 4. We'll start with so in this step 2 we are noting out the phenomenon value that we have taken initially. So initial phenomenon value is 0.5. Since the evaporation count is 0.36, that is 64%, that is 0.64% will remain along the path. We'll multiply all the phenomenon value with 0.64. With this we get this value, that is 0.3 all over. In the step 3, we'll start with node 0. There is no mandate, but it is a good practice to start with node 0. From node 0, we have to find the root, that is node 1, node 3, node 2 and 3. Among these 3 nodes, which node to choose. So for that we have to find the designers. So that is 1 divided by distance. 1 by 10, 1 by 17 and 1 by 10 will get a value, and we have to multiply this value with the phenomenon. So we get 0.32 is the initial phenomenon as we have seen in the graph here. So that will multiply here with 0.1, that is the distance, will get value. So how do we find the probability? As I have said in theory, it is 0.32 divided by sum of all these values. So we'll get 0.8386. Here we'll get, it is 0.019 divided by sum of all these values, we'll get 0.215. And here also 0.032 divided by sum of all these values. It's been taught in the theory. So with this we'll go with the probability graph. So initially we'll note down this with first node, that is 0.386.